Alright, so the next thing we're going to do is I'm actually going to have you do some example and some comparisons, mostly because I want to make sure that you can actually enter this in your calculator without doing something silly. So I will borrow, what's it called? I will borrow $10,000 at, we'll call it, let me go at 8% for 6 years. How much will I owe if interest is compounded? So we're going to compare. Annually, semi-annually. Where did you go? Fixed it. Semi-annually. Looks funny. Quarterly. Monthly. Daily. And my son's watching a train show. I hope it's not too annoying. Continuously. Alright. So let's talk about what n is going to be. So in this case, since it's annually, how many times a year is it? Be 1, right? Semi-annually, n would be 2, right? Because it's twice a year. Quarterly, n would be 4. Monthly, n would be 12. And daily, n would be 365. Sometimes they'll tell you, sometimes they'll say use 360 because apparently bankers can't stand weird numbers like 365. I don't know. And then we don't have an n here. We just use a totally different equation, so it's not even an issue. Just erase that so it's not confusing. So, looking at our problem, we've got P is going to be 10,000, and that's going to be the same for all the equations. R is going to be 0.08, and T is going to be 6. So now what we want to do is plug all that into our various equations. So we'll start off with annually. Now remember our equation is A equals P times 1 plus R over N to the NT. So annually, we'd have 10,000 times 1 plus just 0.08 to the 6 times 1. And what I want to start you on is to realize that before you plug this in your calculator, really the best thing to do is to simplify it the best you can. So for example, you should know that 1 plus 0.08 is 1.08. Honestly, if you don't know it, you could just use your calculator. 1 plus 0.08. No? Really? 1 plus 0.08. See? I was right. I'm just saying. Simplify the thing inside the parenthesis first. Simplify the exponent first. The reason for that is if you plug this in your calculator like this, to the 6 times 1, you're going to get totally the wrong answer because you will have forgotten these parentheses and you will have forgotten these parentheses. It's not such a big deal when n is 1, but when n is not 1, it becomes even worse. So you want to plug this into your calculator and we'll say 10,000 times 1.08 to the 6th. So we've got 15,868.74. Now since this is dollars, we're always going to round off to two decimal places. So 15,868.74. So 15,868.74. So if I compound annually after 6 years, that's how much I owe. Now I'll try it semi-annually. So see if you can get all these set up. Pause this, go make some progress, come back later once you've got it. Because believe it or not, I'm not going to be around when you're doing your homework. You have to do it all by yourself. That's not exactly true. I mean, you can email me if you need help or something, but eventually you're going to actually know how to do it right because you can like test and stuff. Daily and continuously. Continuously.
When a train is really important, railroad people
like that. Okay.
Train.
So I'm just going to get everything started and then I'll plug everything in my calculator at the end. So 10,000, 1 plus 0.08 divided by 2.
Others called it the Golden Streak.
10,000. So you should be making all kinds of progress to the 12th. So like reduce it to that point before you go any further. It just makes things easier before you plug it in your calculator. So you can see this gets really exciting super fast. So what will happen is on your homework, they'll be asking you, you know, is it better to invest 8% compounded quarterly or 7% compounded semi-annually? Or they'll have you do all these, you know, different kinds of comparisons. So just want to make sure you can get all these into your calculator successfully because you'd hate to do all the math right and then, you know, plug in your calculator wrong and be like, darn it. Or another expletive of your choice. 12 times 6. So, for example, on this one, you know, this is going to be a little bit different because I can't do it in my head, first of all. I guess I could, but I'm not going to. You know, it's a repeating decimal, so it's 0.000 or 0.0066666666. So if you do want to go ahead and do it, oops. Try this again. 1 plus 0.006666. Just remember that when you plug that into your calculator, that you want to include as many of those digits as you feel like typing in. You know, so that when you do plug it into your calculator, that it's as accurate as possible. 10,000. This is fun. We get to hang out this way. See, we never just have downtime, you know? You and me doing math problems. So, it's much funner this way. I'm going to leave this one in that form just for the moment so I can show you how you could put that in your calculator if you wanted to. Also, it's going to be pretty big. Can y'all hear that train show in the background? So that sounds really awesome. 365 times 6. 365 times 6 is 2190. Alright. And I'll do the continuously in a minute. So I've got all my little equations now. Now I can just go straight to my calculator and go to town. So 10,000 times 1.04 to the 12. So 16, 10, 32. 16, 10, 32. And then I've got 10,000 times 1.02 to the 24. Enter. So I got 16084.37. So 16084.37. Can you see the difference? Like there's 1610, 1684, so quarterly is a big deal, right? This one. So this is the way you could do this one. 10,000 times 1.00. And I'm going to do just like a bunch of sixes because I know it's a repeating decimal. And when I get tired, I'm going to go to the... And I multiplied wrong because I'm a dork. Oh, I didn't multiply wrong. I just wrote it wrong here. See, that's still a 72. That didn't change. Why didn't y'all say anything? To the 72. Enter. So 16,135.02. 16,135.02, right? Yeah. You know, so you could get a slightly different answer. Say I just done 10,000 times, and say I just done 1.006 to the 72. I'm going to get a different answer. See, Wow, that was a lot differenter than I thought. Like, super differenter than I thought. So, wow, so I'm actually kind of shocked. That made a, like, ridiculously big difference. Decimal points are apparently very important. So, let's actually plug it in with the 0.08 over 12 and just see how off we are, because now you got me worried. 10,000, oops, we need those, times 1 plus, now this is how you have to do it, 0.08 divided by 12, and put all that in parentheses, and now to the 72. Alright, 16,135.02. So we did enough. We put enough extra sixes in there. But you can see that, like, just rounding off or truncating it or whatever, you're going to get a really ugly answer. So, yay! My faith in repeating decimals is returned. Alright, so now I'm going to do my last one of these. 10,000 times 1 plus 0.08 divided by 365 to the 2190. And I'm going to get 16,159.89. So 16,159.89. So let's make our little table for a second, because I kind of wanted to compare it. So annually, we got 15,868.74. 15,868.74. Semi-annually, we got 16,010.32. Come on, 16,010.32. Quarterly, that's a terrible abbreviation for quarterly. We got 16,084.37. And then we had monthly.
In the last century, there were
16,135.02.
Today, there are only a few.
And then daily, got 16,159.89.
Then in 2000, Conrail disappeared.
So you see how these are increasing, which is good because it means we did it right in our calculator. And now we will plug it in continuously, which is our P times e to the RT, which is 10,000 times e to the rate, which is 0.08, times time, which is 6 years. So 10,000 times e to the 0.48. So 10,000 times e to the 0.48 and 16,160.74. So 16,160.74. So continuously is going to be 16,160.74. So you don't see a huge difference between daily and continuously, but it's there. And the more money you borrow over a longer period of time, it's going to make a big difference. So as you can see, definitely the more times that you compound, that makes a huge difference. And that's your exponential curve going to town right there.